Hi friends, now we'll start with fourth chapter part C. Now in which there is a real and apparent depth. Now what exactly is a real and apparent depth? Suppose you are standing near a swimming pool. So you will find that the base of that swimming pool appears to be raised upward. That is, appears to be less depth. But if you enter in that swimming pool, you observe that apparent real depth will be more. Second, there is a bending of stick. If that stick is inserted in a glass in which containing water, if you immerse that part, the point where it enters, it appears to be bent. That is, bending is also due to refraction of light. There is a term called as twinkling of star. Star twinkle, but planets do not. That is also based on the principle of refraction of light. Now, stars is at far distance from the Earth's surface. It continuously emits light. When that light enters our atmosphere, your atmosphere is divided into different layers having different refractive index, due to which there is a change in path, and also due to rotation of Earth, there is a apparent change in position of the that star, and therefore the result of these two parts comes out to be what? There is a twinkling of star. Now, why planets do not twinkle? The planets do not have their own light. So, and they are very close to the Earth's surface, therefore they do not twinkle. That is one part. Now we'll go with one derivation of real and apparent depth. That derivation is not there, so I will draw only the diagram. Now just check. Here is our pond, right? Now this is the water. This is water. This is the source of light. Say point O is the object. This is the first incident ray, that is called as normal incidence. This is the second incident ray, oblique incidence. This is the normal drawn, and this is the refracted ray. Now this is your angle of incidence I. So this is also I. Now if I take this in backward direction, here will be the image form. So object is over here, but image form will be over here. So I can say this is my real depth. This is my real depth. But what is this part? Is nothing but observed depth, that is called as apparent depth. It is called apparent depth. So the difference between these two is called as what? Shift. Difference between these two is called shift. So can I write here, this is I, this is also R, because this is your R. So here we write shift is nothing but difference between real depth minus what? Apparent depth. Now shift is also equal to, it is equal to shift, right now, shift, write here refractive index. This refractive index, that is mu, is equal to real depth upon what? Apparent depth. Then you have one more relation, that is shift is equal to real depth 1 minus 1 upon mu. This is what is a numericals based on this part. Now from this chapter only, this part only, this much is there. Now we'll start with the next part, that is part D, which is very important. The important term over here is called as total internal reflection. I write here, it is part D. It is total internal reflection. Now over here it is reflection, not refraction. It is reflection, called as TIR. It is TIR. Now before we'll start with what is TIR, we'll first write what are the conditions for TIR. Now what are the conditions? The first condition for this TIR is that, so right here what are the conditions? So first condition of TIR is that the source of light must be in denser medium. What is that part? Source must be in what? Denser medium. Now denser medium is what? So if I consider water and air, so water will be considered as denser and air is considered as what? Rarer. So first point, the source of light must be in denser medium, and in that same point, ray of light should go from denser to rarer. Ray of light should go from what? Denser to rarer. Now what is the second condition? Second condition says angle of incidence must be greater than IC. This IC is called as critical angle. Now what exactly this critical angle? That will come after this part. So we'll start with diagram of this part and then I will explain what do you mean by TIR. Now here check. This is our boundary. XY is a boundary separating two media. The lower medium is the denser medium and upper medium is what? Rarer medium. Now here is a source of light. Say this is the source of light. Ray of light is going from now denser to rarer. That is the first condition. This is your normal incidence. Light travels straight without any deviation. Now in second part, this is the incident ray, right? This is the normal drawn. This is the normal drawn. Now it is going from now denser to rarer, so it will bend away from normal. So this is I1 is angle of incidence, R1 is angle of refraction. Now I will increase the incident ray, angle of incidence. This is the normal. This is your angle of incidence I2. This is the refracted ray, which is what? R2. Now third part, this is the incident ray. It will go like this. This is the normal drawn and this will be the refracted ray. So this is your I3, which is called as critical angle, for which angle of refraction R3 is equal to what? 90 degree. So what is critical angle? So right here, critical angle is the angle of incidence in a denser medium for which angle of refraction in rarer is 90 degree. What is critical angle? It is the angle of incidence in denser medium for which angle of refraction in rarer is 90 degree. That is called as critical angle for a given pair of medium. Now this is constant for a given pair of medium. That is, I will write here, it is IC is 42 degree for glass air pair. It is 48 degree for water air. And it is 25 degree for diamond air. So these values are fixed. These values are what? Fixed. So it is 42 for glass, 48 for water, and diamond it is 25 degree. Now what is the next condition? Angle of incidence must be more than critical angle. So this is my incident ray, right? Over here angle is I4, which is more than critical value. So this get reflected back in the same medium. So this is your R4 dash. Now over here your I4 is equal to R4 dash. This is according to what? Laws of reflection. So what is TIR? It is a phenomenon in which ray of light is totally internally reflected back in the same medium from denser rarer boundary. This is what is a TIR. Critical angle is depend on what factor? Critical angle depends on, what is the relation between critical angle and refractive index? Relation is A mu n is equal to 1 upon sine IC, or some people are writing only 1 upon sine C, which is written as what? Cosec C. This is what? Cosec C. So this is important relation. Now critical angle depends on two factors. One is IC is directly proportional to wavelength, that is color, and critical angle is directly proportional to what? Temperature. So these are the two factors on which critical angle depends, right? Now that's it for this video. In the next video we are continuing with the same part where we are using the TIR, application of TIR with the various ray diagram. Thank you.